Welcome again. Today we look at the deduction of the polar nature of covalent bonds from electronegativity values. And first we must recall that electronegativity is the tendency of an atom to attract electrons in a shared covalent bond. So when you have a molecule like this one, the electronegativity of this green atom per se, let's say it's chlorine. The electronegativity of chlorine is the tendency of this chlorine atom to attract and to keep the shared pair of electrons in this covalent bond closer to itself. And electronegativity has no units, for it is a relative term referring to the relative tendency of atoms to hold electrons closer to them. So for instance here in hydrogen chloride, with an electronegativity value for chlorine of 3.2 and hydrogen 2.2, there's a difference of 1 in the values of the two atoms, meaning that the shared electrons here in this covalent bond are held much closer to chlorine than they are to hydrogen, making this particular type of covalent bond a polar covalent bond. And how do we classify bonds as polar covalent or non-polar covalent? We have this scale here that we can use. And here it says that if delta electronegativity, or the difference in the electronegativity values, is somewhere between 1.8 and 0, then we end up with a polar covalent bond, like here in hydrogen chloride. But if we have a case like oxygen, where you have two atoms with the same electronegativity, then delta electronegativity comes to 0, and the bond is described as being a pure covalent bond, as opposed to a polar covalent bond, because the difference in the two electronegativity values comes to 0. And of course we have those cases where you have a huge difference, greater than 1.8 in the electronegativity values, like here in magnesium chloride, for example, where the difference in electronegativity values between magnesium 1.3 and chlorine 3.2 is 1.9. That makes magnesium chloride an ionic compound. Now I would like you to access a table of electronegativity values from page 8 of the IB data booklet and to use it to classify the following molecules either as ionic, polar covalent, or covalent.